This is the basic platform for the GPFR1000. It's comprised of a variable speed AC motor, a polyol gear pump, and an ISO gear pump. In addition, we've got pressure outlet gauges, we've got pressure relief valves on each side. This system happens to have a recirculation mode, so that's not appropriate in the fuller application. So again, a variable speed AC motor. This has a gear reducer to change the speed of the pumps, the polyol and the ISO. These pumps are available in different outputs, for instance 6 cc's per rev or 12 cc's per rev, or whatever is necessary to bring the ratio into a gross adjustment to what's required for the adhesive. Each pump has a wet cup filler here. Put an inert oil in here that's non-hygroscopic, and that oil surrounds the shaft, the output shaft, to prevent moisture from contaminating the seals, especially important on the ISO side. So what ties all this together is the motor and the two pumps, is the gear train or transmission on the front of the unit, and that's also how the variable ratio takes place. So this is the actual transmission, or the area where we change ratio on the machine. There are two thumb screws. Open the cover, interlock to shut the system down in the event somebody opens that while it's running. On the back side is the polyol pump and the isocyanate pump. The main drive for the electric motor is here. Through a series of gears, we drive the two pumps that are located on the back side. The polyol pump remains the same at 100 teeth. The change gear on this side is the isocyanate or the hardener pump, which is adjustable, and that's adjustable between 40 teeth and 120 teeth. So for any given set of pump sizes, we can adjust the ratio by changing this gear. Well, these gears are available from 40 teeth to 120 teeth in one-tooth increments. So as you change the gear one tooth, you effectively change the ratio by 1%. And we can go from here or to a much larger gear here. And what that does is change the output of the hardener or the isocyanate side. Ratio on this machine. We loosen this idler gear. Move it back out of the way. Take the snap ring off. It goes on this gear, the snap ring. Remove the gear. I'll do the reverse procedure to put on, for instance, the smaller gear. That smaller gear goes on. Lower the idler gear onto that, and you're done. And the ratios change. Let's say, for instance, the machine has a 6 cc per rev output on this side and a 6 cc per rev output on this side. This configuration has a 100-tooth gear on this side, so each revolution will produce 6 cc's. We put a 112-tooth gear on this side, meaning the isocyanate will be reduced by 12%. Instead of putting out 6 cc's per rev, it'll now put out 5.28 cc's per rev. So we've changed the ratio from 1 to 1, if this was 100 tooth and 100 tooth, to 1.14 to 1. So you can see how that works by increasing the size of the gear. Essentially, it reduces the output of the isocyanate. So let's say we wanted to go in the other direction. So we go from 112 tooth gear, and remember these are available in one tooth increments. and we put on a 78 tooth gear on the isocyanate side. So what you've effectively done, the output here remains the same at 6 Cs per rev, but you've essentially increased the output of this pump by 22% by putting on a 78 tooth gear. So we've gone in the other direction by changing these gears from larger than 100 to smaller than 100. And if we wanted a one-to-one system, put a 100 tooth gear here and leave this gear as 100 tooth. This remains constant. This is the variable. Okay, so let's assume we've decided that theoretically the 78 tooth gear is the one we need to achieve the ratio we need to do. We slide that on, we loosen the idler gear, engage it, tighten the idler gear. We're going to install the C-clamp clip on here, close the cover, and we're done. So what are the limitations on this? It's basically the speed of this pump back here. We have a limitation on this end of about 40 teeth. If we go much smaller than that, the speed of the pump exceeds what's recommended by the manufacturer. So in that case, if we need a larger output here, we've gotten to 40 teeth, we increase the size of this pump, for instance, from 6 cc to 12 cc's. And then we have a whole range that we can go through again with the gears to achieve whatever we need to achieve. If we get to the point where we've maxed out gears and pumps, and we need to do what we refer to as a reverse ratio, that is, we need 4 iso to 1 poly, what will be necessary is to take the poly pump, put it on the iso side, take the iso pump, and put it on the poly side, and now you can go through all of your gear changes.